Spanning across the vast expanse of the Pacific Ocean lies a sleeping climatic giant, a phenomenon so incredibly powerful it possesses the ability to completely rewrite global weather patterns. It can bring devastating floods to barren deserts and catastrophic droughts to the world's most lush rainforests. This is El Niño, the warm phase of the powerful El Niño-Southern Oscillation, known as ENSO. At its core, El Niño is a profound disruption of the ocean atmosphere system in the tropical Pacific. It occurs irregularly, typically every 2 to 7 years, and can last for several intense months. When it awakens, its effects ripple outward, violently altering the climate of the entire planet. For billions of people and countless fragile ecosystems, El Niño dictates the harsh terms of survival. Our understanding of this massive climatic force began centuries ago, not with scientists, but with fishermen. In the 1600s, along the coasts of Peru and Ecuador, local fishermen noticed a strange, devastating cycle. Periodically, the normally frigid, nutrient-rich coastal waters would become mysteriously and unusually warm. This sudden warming drove the fish away, completely collapsing the local coastal food supply and economy. Because this anomalous warming usually peaked around December, the fishermen gave it a special name. They called it El Niño de Navidad, referring to the Christ child, due to its arrival during Christmas. It wasn't until the 1920s that scientists linked this localized ocean warming to global atmospheric pressure. Sir Gilbert Walker discovered the Southern Oscillation, connecting the ocean's heat directly to planetary wind patterns. To truly understand El Niño, we must first look at the normal, balanced state of the Pacific Ocean. Normally, powerful trade winds blow steadily westward, pushing warm surface water toward Asia and Australia. This allows cold, highly nutrient-rich water to well up from the deep ocean along the South American coast. But during an El Niño event, these critical trade winds suddenly weaken or even reverse direction entirely, without the wind to hold it back. The massive pool of warm water violently surges eastward across the ocean. As the warm water shifts across the globe, it takes the heavy, storm-producing tropical rain clouds with it. This shift completely flips global weather. Areas that expect heavy rain get severe drought, and vice versa. The immense heat released into the atmosphere aggressively alters the path of the global jet streams. El Niño acts as a massive planetary heater, transferring deep ocean energy directly into the Earth's atmosphere. It is a terrifying masterclass in planetary physics, where the ocean and the air dance in a chaotic rhythm. Over the past century, a few El Niño events have been so powerful they permanently changed human history. The 1982-83 event caught the world completely off guard, causing billions in damage and massive ecological loss. The 1997 Super El Niño was even stronger, triggering extreme floods in the Americas and devastating global droughts. In 2015, another monster event pushed average global temperatures to unprecedented record-breaking new highs. Millions faced acute food insecurity, and coral reefs suffered the absolute worst global bleaching event ever recorded. Most recently, the 2023 to 2024 cycle triggered the most severe, punishing drought ever recorded in the Amazon basin. These super El Niños occur when ocean temperatures rise more than 2 degrees Celsius above the historical normal. Each of these titans left a permanent physical scar on the planet, teaching us the true power of climate volatility. Now, in the year 2026, the global climate is once again standing at a highly dangerous, unpredictable threshold. We are still reeling from recent cycles, and baseline ocean temperatures are significantly higher than they were a decade ago. The window of recovery between extreme events is rapidly shrinking, pushing ecosystems and infrastructure to the breaking point. Meteorologists today are closely monitoring subtle, alarming shifts in the Pacific trade winds, preparing for the next swing. With global warming raising the temperature floor, even a moderate El Niño today can trigger catastrophic, unprecedented extremes. We are living in an era of amplified climate volatility, where our historical records are no longer a reliable guide. The most immediate victim of El Niño is the Pacific Ocean itself, particularly its delicate, complex marine ecosystems. As surface waters heat up, corals expel their symbiotic algae, leading to massive, deadly ecosystem-wide bleaching events. The lack of cold water upwelling starves the ocean of vital nutrients, causing the base of the food web to collapse. Fish populations plummet rapidly, leading to mass starvation for marine mammals, seabirds, and dependent coastal human communities. Meanwhile, shifting sea levels and enhanced wave energy aggressively accelerate coastal erosion across vulnerable Pacific Island nations. These abnormally warm waters also act as rocket fuel, spawning intense tropical cyclones in regions completely unaccustomed to them. Thousands of miles away, El Niño plunges the mighty Amazon rainforest into severe, prolonged, and deadly drought. Rainfall drops drastically. The normally humid forest dries out, making it highly susceptible to devastating widespread wildfires. But the Amazon is not passive. When pushed to the brink, these trees unleash a hidden, incredible chemical defense mechanism. During recent record droughts, researchers discovered trees emitting massive amounts of special defense compounds called sesquiterpenes. These reactive airborne molecules act as profound distress signals, helping the forest cope with intense heat and oxidative stress. Incredibly, even long after the drought ends, the trees continue to release specialized protective alcohols like beta-udismol. This newly discovered chemical resilience proves the forest is actively metabolically fighting to survive the changing climate. In Africa, El Niño manipulates the climate with stark, deadly contrasts across the massive continent. Southern Africa typically experiences crippling droughts, devastating staple crops like maize and threatening millions with severe famine. Conversely, the Horn of Africa, a region often plagued by drought, is suddenly inundated with torrential destructive floods. While the rain temporarily greens the desert, the extreme flooding washes away vital topsoil and destroys critical infrastructure. These sudden, intense wet conditions in arid regions also create perfect breeding grounds for devastating continent-spanning locust swarms. Across Asia, the arrival of El Niño brings blistering, deadly heat waves and massive, continent-wide agricultural disruption. It severely suppresses the vital summer monsoons, leading to catastrophic water shortages across India and Southeast Asia. With rainfall heavily disrupted, rivers run historically low, threatening both food security and vital hydroelectric power generation. In Southeast Asia, the dry conditions massively exacerbate forest fires and agricultural burning, choking the region in toxic haze. The intense, prolonged heat also accelerates the melting of Himalayan glaciers, threatening long-term freshwater supplies for billions. The economic shockwaves are profound. Massive crop failures in Asia reliably trigger sharp spikes in global food prices. El Niño is a natural cycle, but its destructive impacts are being massively amplified by human-driven climate change. To lower its impact, humanity must first heavily invest in advanced early warning systems and deep ocean monitoring. Global agriculture must adapt rapidly. Planting drought-resistant crops and radically improving water conservation can save millions of livelihoods. Ultimately, to reduce the extreme severity of future El Niños, we must aggressively and permanently cut global carbon emissions. Restoring natural environmental buffers like mangroves and coral reefs helps protect vulnerable coastal communities from intense storm surges. By halting the relentless rise in baseline global temperatures, we prevent El Niño from pushing weather into uncharted fatal extremes. We must fundamentally rethink how we manage our fresh water, treating it as the precious, finite resource it truly is. International cooperation is absolutely vital. The climate knows no borders, and neither should our solutions to fix it. Nature has shown us its incredible resilience, from the chemical defenses of the Amazon to the endurance of the deep oceans. But nature cannot fight this battle alone. It is up to humanity to forge a sustainable, lasting balance with our planet. Thank you for watching. How can we better prepare for the changing climate? Let us know your thoughts in the comments below.